Okay, so this is section 10.5, angle relationships in circles. The chapter jumps right into more circle theorems. So we have theorem 10.14, which is the tangent and intersected chord theorem. It states if a tangent and a chord intersect at a point on the circle. So here we see that point A is on the circle. So if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So we see that angle 1 is 1/2 of arc AB, as they've written down below, and we see that angle 2 is equal to 1/2 of arc ACB, which they've written here as well. So a circle has an interior, an exterior region, and the circle itself. So any point on the circle itself will create 1/2 the intercepted arc measure. Plain and simple. From there, we can apply this and see that angle B is on the circle. So angle 1 has 1/2 the measure of the arc that it intercepts. That arc is 130. So we can say that the measure of angle 1 is equal to 1/2 of 130 degrees. The measure of angle 1 is 65 degrees. In example B, we see that L is a point on the circle. So this angle that is formed by L is 125 degrees. We can say that the 125 degree angle is equal to 1/2 of its intercepted arc. We see that that is arc LJK. So 1/2 of the measure of arc LJK. And to solve, we can multiply both sides by 2. And that gives us 250 degrees is equal to the measure of arc LJK. So they're both using the same theorem, just one you're solving for the angle for part A, and then in part B you're solving for the measure of the arc it intercepts. Intersecting lines and circles. If two non-parallel lines intersect a circle, then there are 3 places where the lines can intersect: on the circle itself, the interior region, or the exterior region. And we've seen the theorem when it intersects on the circle will be 1/2 the intercepted arc. Now let's look at the theorem for when it intersects in the interior region. So there's the interior intersection. And theorem 10.15 states if 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So we see that angle 1 intercepts arc DC, and the vertical angle to angle 1 intercepts arc AB. So we have this formula here. Angle 1 is 1/2 the sum of DC plus AB. So if the angle vertex is from 2 intersecting chords and the intersection occurs in the interior region of the circle, we are using addition. We're adding up the 2 intercepted arcs by the angle and its vertical angle. And now we can see that for angle 2's vertical angle intercepts arc AD, and angle 2 intercepts arc BC. We add those 2 together and take half that sum to find angle 2. Theorem 10.16 addresses intersections that happen in the exterior region. And they've drawn out 3 different scenarios for the exterior intersection. And the theorem for 10.16 states if a tangent and a secant, or 2 tangents, or 2 secants intersect in the outside region of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. I just like to add, instead of difference, I like to say the positive difference. The positive difference occurs when you take the larger number and you subtract the smaller number. For example, 3 minus 2 has a positive difference of 1, but 2 minus 3 has a difference of negative 1. But if you ask for the positive difference of 3 and 2, you would say positive 1. You would take the larger number and subtract the smaller. Well, we can see that we have a large arc and a small arc. We're going to take the large arc minus the small arc to get the positive difference. And we'll do that for each case. So example 2, we have to determine which formula we're going to use. Because in problem A, the intersection occurs in the interior region, we're going to use the formula that takes the sum of the arc that is intercepted by the angle and its vertical angle. So here is angle X. It intercepts the 156 degree arc KL. Its vertical angle intercepts arc JM, which is 130 degrees. And again, because it's interior, we're going to take the sum and then half the sum. So the measure of angle X is equal to 1/2 156 plus 130. That gives us 1/2 of 286, which is 143. So X is 143 degrees. Problem B, we see that the intersection occurs in the exterior region of the circle. So now we want to take the positive difference of the intercepted arcs. We see that the larger intercepted arc is 178 degrees. So the measure of angle X is equal to 1/2 178 degrees. We're looking for the positive difference, so we take the larger intercepted arc and subtract the smaller. And now we can see that the measure of angle X is 1/2 of 102 degrees. X is equal to 51 degrees. Okay, so on this slide, we're defining a circumscribed angle. A circumscribed angle is an angle whose sides are tangent to a circle. We see we have a tangent point at A and a tangent point at C. Whenever we see we have tangent points, we can draw in a radius to that point and understand it would be perpendicular to that line that's connected to the point of tangency. That becomes helpful because if I were to draw this in for both of them, we should understand that this is a kite because radii are congruent. And we learned in an earlier part of the chapter that lines tangent to the same circle that intersect at an exterior point create a congruent segment out there. So here we have a quadrilateral with two pairs of consecutive congruent segments. This is a kite. And we were able to introduce that it was a kite because we were told that these lines were tangent, and we were able to construct more to it from there. Additionally, the circumscribed angle becomes important when we talk about circumscribed polygons. So if these lines were all tangent, let's just assume I drew them all tangent here, that would be a circumscribed polygon, and they each have circumscribed angles inside of here. So this theorem would apply, and we would know that these segments would all have to be congruent from the previous theorem we learned in the chapter. So 1017 gives us the circumscribed angle theorem. It says the measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. So we see that the measure of angle ADB is equal to 180 degrees minus angle ACB and this should be easy to see that if I were to extend this and create a diameter, that would be the 180 degrees. And this is the difference that comes from 180 degrees minus angle ACB. And we're dealing with half a circle instead of the whole circle. And that's why it is equal, where traditionally we would say that angle D is equal to 1/2 the measure of arc. Let me put a letter out here and say BXA minus the measure of arc AB. This is dealing with the whole circle, 360 degrees, and this is focusing on the half circle, and that's why it negates this need for the half, and why we can solve it more directly if we know the measure of the central angle. So some of the benefits is if you can, you solve it using the theorem we just discussed in the previous slides, taking the positive difference and 1/2 the measure. Or if you're given the central angle or can find it, then you can use theorem 1017, but they are both accomplishing the same thing, finding the measure of an exterior angle that is tangent to the circle. So here we can say that x is equal to 180 minus 135. X is equal to 45 degrees. So problem B is going to ask you to solve for x, but notice that x is not a central angle. So we need to first solve for the central angle. If I draw the central angle in here, I see that angle G would be my central angle, and it's related to the 30-degree exterior angle. We can say that 30 degrees is equal to 180 minus the measure of angle G. And then we can do some algebra and move angle G to the left-hand side and let it be equal to 180 minus 30. So the measure of angle G is 150. And if the measure of angle G is 150, so is the arc it intercepts, because the central angle is equal to the arc measure. So this is 150. And x is an inscribed angle, so x is equal to 1/2 the intercepted arc. It intercepts the 150-degree arc, so x is 75 degrees. Okay, so that is the end of this presentation. Watch the video over, pause it, take notes, and complete the assignment.